Ever sent an email and wondered how it magically appears on someone else's screen halfway across the world? Or how you can binge watch your favorite shows on demand? It all seems like magic, but it's actually thanks to one of the most incredible human inventions, the Internet. At its core, the Internet is just a massive, global network of connected computers. But how does it all actually work? Let's break it down. Think of the Internet like a giant library. When you want a book, you go to the librarian and ask for it. On the Internet, your computer or phone is the client. You're the one asking for information. The server is like the library that stores all the websites, videos, and data. When you type a website address into your browser, you're sending a request to a server somewhere in the world. But how does your request find the right server, and how does the server find you back? That's where IP addresses come in. Every device connected to the Internet, from your laptop to the massive servers hosting YouTube, has a unique IP address. It's like a postal address for your device. So, when you request a video, your device says, "Hey, I'm at this IP address, and I want to see this video from that server's IP address, and who manages all this traffic?" Your Internet Service Provider, or ISP, they are the postal service of the Internet, connecting your home to the wider global network and directing your data to where it needs to go. Now, things get really cool when we look at how the data actually travels. Sending a huge video file all at once would be slow and inefficient. Instead, the Internet uses a clever trick called packet switching. Your video is broken down into thousands of tiny pieces called packets. Each packet is labeled with the destination IP address and information on how to reassemble it. These packets then travel across the Internet independently, like a fleet of delivery trucks all heading to the same address, but taking different routes. Some might go through fiber optic cables, others might bounce off a satellite. The protocol that manages this whole process, ensuring every packet gets there and is reassembled correctly, is called TCP/IP. It's the rulebook of the Internet. But wait, we don't type in long strings of numbers to visit websites, right? We use names like youtube.com. This is thanks to the Domain Name System, or DNS. The DNS is the Internet's phonebook. When you type in a website name, your computer asks a DNS server, "Hey, what's the IP address for youtube.com?" The DNS server looks it up and sends back the correct IP address, so your browser knows which server to connect to. It happens so fast you don't even notice. All of these digital packets are zipping through a mind-boggling physical infrastructure. We're talking about millions of miles of fiber optic cables laid on the ocean floor, connecting continents. We have giant data centers the size of shopping malls, powerful satellites orbiting the Earth, and countless cell towers blanketing our cities. When you stream a video from a server in California, those data packets might travel through an undersea cable to Europe, get routed through a data center in London, and then beamed to your phone via a local cell tower, all in a fraction of a second. So, to recap, you, the client, request information. Your ISP connects you to the Internet. The DNS translates a website name into an IP address. The data is broken into packets, which travel through a massive physical network of cables and satellites, all governed by the rules of TCP/IP, and finally, the packets are reassembled on your screen. The next time you send a message or watch a video, just take a moment to appreciate the incredible, complex, and invisible dance of data happening behind the scenes. It truly is a modern marvel. Thanks for watching, and if you're curious to learn more, make sure to subscribe.